Looking in more detail at the inverse trig function for sine, what we find is that since an inverse undoes a function, to undo the sine of x, we will create the inverse sine of x. What this means is if we have some angle theta, performing the operation sine of theta gives us that the sine of theta is opposite over hypotenuse. But to get back to theta, undo the function, we perform this operation inverse sine of theta. Graphically, you should remember that the idea of an inverse looks like the reflection of the original function across the line y equals x. Remember, in an inverse, we take x and y and we switch them. Y becomes x. So if we look at the graph of sine, notice it's not 1-to-1. It does not pass the horizontal line test. However, if we restrict the domain between pi over 2 and negative pi over 2, that does create a 1-to-1 function right here. If we then reflect this part of the graph and this part of the graph only across the line y equals x, which is indicated here in blue, then we get this inverse trig function of sine, which is shown in green. Notice that if we look at just that inverse trig function, so this is the inverse sine of x, the domain of the inverse sine of x is between -1 and 1, and the range is between negative pi over 2 and pi over 2, which is the reverse of the domain and range that was shown here when we restricted the domain. This will come in handy as we make calculations later.